Hey there, everybody. Welcome to Takeo After Dark. John Barba with Jason Cox. How we all doing? I've got Tim Ward. I see Tim Ward is logged in from Mechanical Hub, but I don't see Tim's handsome face here.
Mr.
So how are
Barba,
I
Mr.
hear
Barba,
I
I'm
hear
here for
his
some
voice?
reason, technical difficulties. I'm not able to show my webcam for some reason.
Well, I've seen you in person. That's probably not a bad thing. I'm not one to I shouldn't be one to talk either. There, Tim. So
Well,
how we
we're doing good on this end. In fact, I just saw Dave a couple weeks ago at the Eastern Energy Expo, and him and I had some time together. Talked a lot about things over the last few months. This is a busy time. Well, it's been a very busy first 5 months for Mechanical Hub, and we're kind of taking a little bit of slowdown right now. In fact, as we speak, I believe the lovely Heather and Eric are plane bound to Rome.
they Heather and Eric spend more time abroad, I think, than they do in Minnesota. God bless him. Man, the man works hard, and he deserves a little European vacation
No
every
doubt
few
about that.
months.
They're doing a little Italy and Croatia. John is meeting me this weekend for a NASCAR race in Michigan, so
Oh,
we're gonna
very
have some
good.
fun up in the Irish hills of Michigan. So yeah, but for those of you, if you don't know Mechanical Hub, just Google Mechanical Hub. Go to our website, see all our videos, podcasts, Make Trade Great Again podcast with Eric and Andy, and of course, Appetite for Construction with John and I.
And it's good stuff, absolutely good stuff. And we're so appreciative of you guys partnering with us. Oh, these 5 years now on
Yeah,
Takeo After Dark. My
I was
goodness.
going to say
Yeah.
that little pandemic back in the early 2020s kind of got this all started.
It surely did. It surely
I
did. It
heard something.
surely
I
did.
heard something was going around back then.
Yeah. It's still just to this day, I start thinking about what we were going through back then and how we kind of what was considered the new normal. It was crazy. It was just crazy. But
Yeah.
hey, thank God it's in the rearview mirror and hope it doesn't happen again. Hope it
Well,
doesn't
Hopefully we
happen
learn.
again.
Hopefully we learned something from it
we
too.
did, and I think most people in the world found out how essential this industry is.
That's
Very
absolutely
good.
right. Absolutely,
It's a great
absolutely
spin.
right.
That's a great way to look at it.
There we go. Well, hey, listen, Tim, thank you so much for being with us. We appreciate it. Tonight's, I'm really excited about tonight's episode because we're going to get into some real nitty gritty about ModCon boiler piping. Not only are we going to discuss the three different ways to pipe it up, more importantly, and this really hits close to home, is how important sizing the boiler circulator properly can be. I had a guy in yesterday who was working on. We installed a mini split in our apartment for air conditioning and heating, and we've been having some issues with it. And he came in and he was talking about how he just doesn't like to do modcom boilers anymore. He says nothing but troubles with them, nothing but, and it's like every 3-4 years, once it's installed, something catastrophic goes wrong. And I said, I said, I think I know why. And he says, yeah, they're pieces of crap. He says, no, I don't think they're pieces of crap. I think they're very fine pieces of equipment. We oversize the pumps. We go crazy on the pump sizing for both the boiler and the system, and then together that wreaks havoc with all the moving parts to the point where we don't really fully appreciate. So that's what we're going to talk about tonight, and I'm pretty excited about that. It's really going to be an interesting. I think that's going to be an interesting conversation tonight. So that is our discussion this evening. We're going to be talking about ModCon boilers, buffer tanks, closely spaced tees, hydraulic separators, and then some zoning stuff and sizing those circulators properly. So again, tip of the cap before we get started to our patron St. Bruce Campbell, the most interesting actor in Hollywood in my opinion anyway. But he's our guy, has been since day one. I think just because we found a picture of him with an ascot and we thought it looked cool. So since then he's been our guy going back to 2020. Our theme this spring has been power trios in honor of
Mhm.
Jason, Dave, and myself. So we've been going through some of the great power trios. We had Cream, we had the James Gang last week. I mean, we've had a bunch of other different power trios. Tonight's power trio is one of the most unsung rock acts of the early 70s. And every time I listen to these guys, I think, how come they weren't huger than they were? It's Grand Funk Railroad. Now, Tim, I know you remember Grand Funk Railroad. This was kind of your era, like it was mine. And I can remember just thinking, these guys are freaking awesome. Grand Funk Railroad, three guys, Mark, Don, and Mel, were just they just rocked out like crazy. They were a bunch of guys from Michigan, grew up in the Flint area, and they just became a power trio in the late '60s, early '70s. So I'm gonna take the Don Farmer role as the leader of the gang. Jason, I'm giving you the best head of hair because Dave ain't here, right?
Right.
So, and Dave's going to be the bass player because the bass player is always replaceable. Um, don't tell Dave I said that. Don't tell Dave I said that.
I won't.
There we go. And Dave, of course, says Dave's not here, man. Dave's not here.
Where's Dave, man?
Dave's not here, man. Dave is on a trip with actually with a manufacturer, with one of our OEM customers. They're bringing a bunch of their customers out on a little fishing vacation up in rural Maine, and he's in a spot where he doesn't even have internet. That's how far out there he is. So he is
Far out, man.
living the life up there in the woods. So we won't be having Dave tonight to kick around, but we got Jason, we got me, we got Tim Ward. That's all we need, man. That's a power trio right there. That's right there. And Robert Kaplan, remember, they were huge, man.
They had a huge following.
Oh yeah.
They just didn't have a lot of like radio hits, right?
Oh, they did they had that the Locomotion. They redid the Little Eva tune, that Locomotion. They had Some Kind of Wonderful. Closer to Home. Remember that long ballady type song, Closer to Home, was a huge hit. They had some great stuff, but man, some of the jams they would do would be just awesome. I mean, they really were a very powerful power trio. And Robert Kaplan remembers, they were huge, man. They were huge. Do me a favor, gang, just so you know where we're at. Just type in where you're from and where you're coming from and all that. I know we got some foot stomping music. That's right. A bunch of albums. Absolutely. I love it that guys remember a band like Grand Funk. That is awesome because they were one of the best. We got Sheridan, Wyoming. Aaron Bruce from Sheridan, Wyoming. Just chime in from where you're hailing from tonight, so we know A, you can hear us, and B, you're out there and breathing.
Where's all my West Coast people?
Well, we got Orlando. That's not really West Coast. Toronto, no. We got Nash Vegas.
Oh, there's Ontario. We got
Ontario, California. All right.
There we go. What's up, dog?
And Jessica from Phoenix. Welcome, Jessica. How are you?
All right, Jessica.
And, okay, Randy's from Ontario, and no, Randy's from he's from Nash Vegas. All right, cool. Excellent. Well, welcome. Great, folks. We're so happy to have you with us. Let's get this show rolling. We're going to be talking tonight. As always, ask your questions. Jason's going to be monitoring, and then he'll interrupt me every few slides, and we'll try to answer your questions as we go. I don't like waiting for you're holding off to the end. Hold all your questions to the end. That's like the speaker's way of saying I don't really want to hear from you till I'm done talking. So ask your questions as they come up, and we'll try to answer them as we go along. So we find that works best. So tonight we're going to be talking about ModCon boiler piping and pumping. ModCon boiler piping and pumping. We're going to talk about the three different ways there are to pipe up a ModCon. There's the most commonly used closely spaced tees. We're going to talk a little bit about low loss headers. And then finally, we'll talk about buffer tanks. This is all in the first half of the show. We're going to talk about what they are, what they do, and when you might use them and why. Why you might use a buffer tank instead of closely spaced tees. When would a low loss header make more sense than a buffer tank? That sort of thing. It's not really saying one's a blanket better than the other. There are times and instances where one makes more sense than the other, and we're going to go over that. And the biggest thing is, what's with that boiler pump, man? If there's not a pump in the boiler, which many times they have a pump in the boiler. If there isn't one in the boiler, how do you know that you have the right one that you have to field install? And what are the ramifications of oversizing that? Because it's almost impossible not to. What are the ramifications of doing that? And we're going to show you in some pretty graphic detail what can happen and how they can really start to create a myriad of problems with your boiler in a relatively short period of time. So let's talk about the three options. We've got your closely spaced tees, which everybody seems to use because that's your go-to piping arrangement, most commonly used. low loss headers, or they go by many names, but we call them a low loss header, simply because it's the most descriptive, right? It's a low head loss header. It's a packaged header designed for very, very low head loss. And then buffer tanks. And again, it's just a tank that serves as a buffer. Really, it's a big low loss header if you want to think about it. It's a really big low loss header. So that's kind of important there as well. So we'll discuss all three of those things, but we're going to talk about, I think, basically the three W's. What are they? When should you use them, and why would you use one over the other in specific instances? Okay, so we're gonna hit on that three W's theme the whole evening. So that will be our approach. Regardless of which one of those three options you choose, folks, it's all about hydraulic separation. The whole point of using closely spaced tees, a low loss header, or a buffer tank, the whole point is hydraulic separation. We're separating the system flow from the boiler flow because they're not the same. You require a certain flow through the boiler. You require a different flow through the system. How do we get these two things to work together without interfering with one another? That's kind of the whole point here. So it's all about hydraulic separation. So we want to keep the flows separate. So if you can follow my cursor with these closely spaced tees right here, and when these circulators are running, flow through my heating system, all right, flow through the heating system, flow through this header right along here, flow through that header, will not create, influence, or otherwise impact flow through the boiler. Conversely, flow through the boiler will not create, impact, or otherwise influence flow through the system. We hydraulically separate the two to varying degrees. They're going to have an impact on one another, but one's not going to take away from the other. Okay, there's going to be a lot of mixing and stuff involved that we have to pay attention to, but hydraulic separation simply means when the boiler pump is running, it's not going to make water go through the system, and when the system pumps are running, they're not going to make water go through the boiler. That's the whole point when we talk about hydraulic separation. We want to keep those flows separate, and we want to make sure, again, the circulators don't interfere with one another. They play nice together in the same sandbox. So here we show, a hydraulic separator or a low loss header. Really, if you look at it, it's kind of, you got four holes here, right? Four ports in your closely spaced tees. Your system return, your boiler supply, boiler return, boiler supply, system supply. Okay, there's your 4 ports there. We have the same thing here: boiler supply, boiler return, system supply, system return. Now with hydraulic separators, they'll do some funky things. Maybe they'll put in some air separation medium or a magnetic dirt separator built in, or maybe it's just a big open space in the piping and you add that other stuff later. It really depends on what you're using. But it's the same idea, only there's more mass involved, okay? And there will be instances where it makes the most sense to use that. And then lastly, a buffer tank, and it's kind of obvious from this picture. If you take a look at the hydraulic separator, right? Buffer tank's the same thing, only bigger. All right, it holds a lot more water, and there will be specific instances where this is a very advantageous solution for you, but it's just a big hydraulic separator. All righty, cool beans, cool beans. Closely spaced tees. Let's take a look at closely spaced tees. Now, the one rule everybody knows about closely spaced tees is they got to be closely spaced. How close? Well, it's kind of impossible to have them too close, right? I mean, if you get them butt up together like that, that's not bad, okay? That's not bad. You don't want them too far apart, but it's impossible to have them too close unless they're on the other side of one another, right? Again, so close you're behind me. We talk about 4 pipe diameters, 4 pipe diameters max, center to center. That's a guideline. I mean, you go 5 or 6, you can. Some people say 12 inches. Yeah, 12 inches is fine, okay, but the closer the better. That's why you keep them as close as you possibly can, because what we're trying to do is minimize the pressure drop between these two tees. Remember, water's lazy and stupid, right? Water's lazy and stupid. Water just wants to go and it wants to take they call it the path of least resistance, but really all water wants to do in a closed loop system is get back to the suction side of the circulator that's making it move with as little effort as possible. That's its happy place, right? That's its happy place. It just wants to get back to the suction side of the circulator. So if I had a circulator over here, if you can see my cursor over here on this on the supply pipe going out, and I've got water coming through this into this first T, if the circulator on the boiler is off, where's this water going to want to go? Is it going to want to go up here and check out what's up here just because it's curious? Or is it going to say, you know what? The easiest way for me to get to where I want to be is just to keep going straight along this way. If that's the easiest way for it to get to where it wants to be, that's what it's going to do. All right. So we want to virtually eliminate pressure drop. Here's what we're going to talk about this in a little bit, but I want you to remember this phrase as we move along. What goes into a T has to come out of a T. Doesn't, you know, if I got 6 gallons a minute coming into a T in one way, shape, or form, I got to have 6 gallons a minute going out of the other 2 holes. Some combination that's going to equal 6 is going to have to come out of the other 2 holes. So it could be 1 gallon a minute going up into the boiler and 5 gallons a minute going through the system, or some such combination. What goes into a T has to come out of a T. All right, that's the important part. All righty. The 3 W's for closely spaced tees. This is your go-to ModCon piping arrangement. Most ModCons out there are piped just like this. A lot of manufacturers will build you this little rig and say, here, just make these connections and do it this way. So we don't have to think about anything. And that makes it pretty simple. So it's your go-to ModCon piping arrangement. When should you use this? This is where we've got to think a little bit. This is perfect for your single zone repipe, man. This is absolutely perfect for a single zone repipe. Where we start to run into issues is when we have multiple zones and this type of a piping arrangement. This will work just fine if you have multiple zones and the load of each zone, the BTU load of each zone is greater than the boiler's minimum firing rate. Just keep that in your head. Whatever the minimum firing rate, whatever the turn down ratio is, the minimum firing rate of that boiler, if the smallest zone is bigger than that minimum firing rate, all right, we're okay. This will work and work just fine. Okay, it's when we start getting into smaller and smaller zones where this thing starts to be problematic. Okay, we will get into that in gloriously graphic detail momentarily. And then why? Hey, it's simple and it works in most applications. That's the why. It's simple and it works in most applications. So straightforward. 4 pipe diameters, keep those T's as close as you can. And this gives an homage to Rick Mayo again. He used to do this all the time. Keep those T's as close as you can. All righty. Now the hydraulic separator or low loss header. It's the same thing, only bigger, only a little bit more mass. The name says it's all. It's a hydraulic separator. It hydraulically separates the system from the boiler. All right, so flow through that boiler side is not going to impact flow through the system side and vice versa. So the name really says it all. And here you see an up close and personal look. And in this, some of these models, they'll have an air separator medium, so it takes the place of an air separator or serves the purpose of an air separator. And then at the bottom, you might have a collision medium and a magnet where it could serve as a magnetic dirt separator as well. Some of them will do that, and some are just simply chambers, and you just work with that. But again, the name says it all. It's a big open space in the piping. All right, it's a big open space at the piping. There's going to be some water temperature mixing in here, just like there are with closely spaced tees, that we have to be cognizant of. That's why some of the larger low loss headers will have, you see where it says system sensor if applicable. Some of the larger low loss headers will have that port for a system sensor. So when for the boiler, you could connect a boiler sensor in there to sense the water temperature going out to the going out to the system. So the boiler has to work to make the temperature, make the temperature for the system. That might be high, the boiler might be making water temperature that's higher than that, but because I'm going to be mixing some cold return water with this hot boiler water, I've got mixing going on right here. So I got to mix those two to give me the system temperature that I want. So there's, again, it's a nifty control strategy. It's one we will also use with buffer tanks as well when we get into buffer tanks. But again, our goal here is to separate the boiler flow from the system flow, and that's really all it needs to do. Really all it needs to do. Now, the 3Ws here, the 3Ws with the low loss header, hydraulic separators, really in its simplest form, it's a packaged set of closely spaced tees, all right, with a little bit of mass built in. Some have a lot of mass, some have very little mass, but it's simply, it's a packaged set of closely spaced tees. When should you use this? Multiple zones. When you have multiple zones that are all about the smallest zones, maybe about the same as the minimum boiler firing rate. Okay, your zones are all about the same size as the minimum boiler firing rate. That's the best application for this. And the why really is convenience and space. All right, it's packaged piping for you. If it includes your air separation and magnetic dirt separation, well, now you got a threefer, right? You got a threefer in one package. Sure, it's more expensive to buy than the individual components, but it's one thing to put in the system. So that threefer might be more convenient, might save some space, might save some labor. All right, quick status check. How are we doing out there, gang? How's the pace? Is everybody happy? Are we doing good?
You're doing great. You're doing great. Not a lot of questions just yet. We're just rolling up our sleeves now.
All righty. Well, make sure, guys, you chime in. You chime in as soon as we say something crazy, and believe me, that's coming. All right, buffer tanks. Same thing, only bigger, man. Same thing, only bigger. It's a hydraulic separator that's bigger. That's really all you can say about a buffer tank. And with a buffer tank, man, it's all about the mass. We want water content. It's ironic. I think we spend so much over the decades. We've been getting boilers smaller and smaller and smaller, and lower mass, lower mass, lower mass, lower mass. Now all of a sudden we got to add mass to that low mass boiler. Hey, that's life, right? You want something as highly efficient as a ModCon boiler. Mass is has to be low mass. You've got systems with a lot of zones. We got to introduce mass back into the picture, and we do that just with a thermal storage buffer tank. All right. Here's your schematic. It's pretty simple. You got a gazinta and a gazouta for the boiler side, and a gazinta and a gazouta from the system side. It's all pretty simple. Very simple piping schematic. Where it gets interesting is how do you size one? How do you size one? Well, let's take a look at that because it's a pretty simple three-step process. And again, make sure if you got your notepad with you, write these steps down. We've previous sessions, we've given that the takeaway sheet. Formulas are in there as well. And if you again, if you want to just, you'll be getting recording this tomorrow, so you'll be able to go back and review as well. But the question is, how do we size one? How big of a one do you need? Three steps. Step one, you want to determine the minimum boiler firing rate and the smallest zone in terms of BTU. So what's my minimum boiler firing rate and what's the BTU load of my smallest zone? All right, so let's say I have a 150,000 BTU ModCon boiler with a 10-to-1 turn down ratio. Well, my minimum boiler firing rate is 15,000 BTUs. My smallest zone is 7,000. I start with that minimum boiler firing rate minus the BTU load of my smallest zone. All right, my smallest zone gives me the BTU surplus, All right, the BTU surplus. Next, the BTU surplus times your desired minimum runtime, we will default to a 10-minute minimum runtime, meaning every time that boiler fires, I want it to fire for a minimum of 10 minutes. I'd like it to fire longer, but a minimum of 10 minutes. That's my minimum target. All right. So my BTU surplus times my desired minimum runtime of 10 minutes. That's going to give me something called the cycle factor. All right. That's step two. Step three, I'm going to divide the cycle factor by my heating system side delta T times 500. All right, delta T times 500. That's on the system side, not the boiler delta T, the system delta T. So cycle factor divided by delta T times 500 is going to give me my tank capacity in gallons. Okay, it's my tank capacity in gallons. So let's take a gander. Let's go to our 150,000 BTU ModCon boiler with a 10-to-1 turn down ratio. All right, so my minimum boiler fire rate is going to be 15,000. My smallest zone in this example I'm going to use is 5,000 BTUs. So step one, 15,000 minus 5,000, that's going to give me a BTU surplus of 10,000. So I've got a 10,000 BTU surplus. Step two, I'm going to multiply my BTU surplus times my desired minimum runtime of 10 minutes. So 10,000 BTUs times my 10-minute minimum runtime, that's going to give me a cycle factor of 100,000. 100,000. Now I'm going to divide that by my delivery side delta T times 500. Now in this example, if you're taking a look at this, this is a radiant system that we're designing to a 10-degree delta T. All right, not a 20. It's going to be a 10-degree delta T. So 10 times 500 is 5,000. 100,000 divided by 5,000 means I'm going to be using a 20-gallon tank. I'm going to be looking for a 20-gallon tank. All right. What if you can't find a 20-gallon tank? Are you saying, I can't do this. I can't find a 20-gallon tank. There's no crying in hydronics. All right. Jimmy Dugan said there's no crying in baseball. We say there's no crying in hydronics. If you can't find a 20-gallon buffer tank, what are you going to do? Look for something that's close. Look for something that's close, man. Let's say you can only find the closest you can find is a 25-gallon tank. What's the worst thing that's going to happen if you put a 25-gallon tank in here instead of a 20? What's the worst thing that's going to happen? Tick tock, tick tock, tick tock.
Slow recovery.
Well, it's not a recovery tank. It's not a recovery tank. It's not an indirect, right? It's just a storage.
Ahmad says it'll take more time. I'm assuming take more time to heat up the water in the tank. Longer cycle time, says Scott.
Longer cycle time, exactly.
There you go.
My minimum runtime won't be 10 minutes. Maybe it'll be 12 or 13. That's not a bad thing, right? That's not a bad thing at all. All right. More heat loss? Not really. It's going to be an insulated tank. And again, it's not an indirect tank. It's just a big empty tank. All right. It's a big empty tank. So we're not worried about getting this done speedily. We want, we got time on our side. We want a nice long minimum run time. Okay. So if we have to go with a 25-gallon tank instead of a 20-gallon tank, okay. So my minimum run time is going to be 12, 13 minutes. Okay. I'll deal with it. That's not a bad thing. If I could only find a 15-gallon tank, well, then use a 15-gallon tank. At that point, the worst thing that's going to happen is maybe your minimum runtime is 8 minutes. Okay, not ideal, but it's better than not having one in at all and having a minimum runtime of about 20 seconds, right? Which is really the alternative if you have a lot of small zones, right? If you have a 5,000 BTU zone and you're using closely spaced Ts, that 25, 30-second minimum runtime is a real fact of life. And when you have 25 or 30-second runtimes on a ModCon boiler, you've got stuff turning on and off and on and off and on and off and on and off. And when things are turning on and off and on and off, they're going to wear out prematurely. All right. So yeah, anything's better than nothing at this point. If you can't find a 20, you use a 15, or if you find a 25, you use 25. Life is better than without having it at all. All right. So that's kind of how you size a buffer tank and why you might want to use one in that respect. And again, we're not, it's in terms of, we saw a question here about, what we're putting the hot water into the top. Yeah, it's fine, because what we're doing is we're mixing inside the tank. Okay. My hot comes in, my supply comes out. There's going to be a mix because the flow rates are different going in between the two. We're going to have some mixing up in that upper portion of the tank, which is why your sensor goes there. So again, not a huge concern at that point. All right. The buffer tank 3Ws. All right. The buffer tank 3Ws. It's a really big hydraulic separator, man. It's a really big hydraulic separator. And when do you use this? When you have a lot of zones that are smaller than the lowest boiler firing rate. All right. A lot of zones smaller than the lowest boiler firing rate. And we're trying to minimize the ticking time bomb that is short cycling. All right, because short cycling doesn't do your boiler any favors. It's never as efficient as it could be or should be. And when you start turning things on and off every, a bunch of times every couple of minutes like that, you're going to wear out parts and pieces. Okay, ignition modules, blower motors, different parts and pieces, things that are expensive to replace. They will go quickly. And that's why, again, my guy was saying he was having nothing but problems with ModCon boilers. There's a reason. One of them is this. Another one is something we're going to talk about in just a couple minutes. All right. Jason, are you ready for Takeo trivia time, my man?
Let's do it. Let's do it. You always surprise me with your trivia questions. Let's go.
Well, hey, this is a good one. This is a good one. And the sound you're hearing is people firing up Google right now.
Don't do it, guys. Fight the feeling, ladies and gentlemen.
Oh, you're going to have to, because this is, you got to really be a Grand Funk Railroad music dork to know this off the top of your head.
All right.
And by golly, if you're one of those and you know this off of the top of your head, I love you, man. You are my kind of people. So Grand Funk Railroad, 3 members, Mark Farner, Don Brewer, and Mel Shocker. They all hailed from Michigan, okay? Mark Farner was the singer, guitar player. Don Brewer was a singer and drummer, and Mel Shocker was the bass player, all right? Mel Shocker was the bass player. Now, Mel Shocker came to Grand Funk from another Michigan band, and that band actually had a huge classic rock #1 hit in 1966. All right.
Oh man.
Your task, if you choose to accept it, is to find the name of that band and the name of the hit. Again, 2-parter. What was the name of the band that Mel Shocker played bass for? And what was their smash humongous #1 hit from 1966? And in fact, it was kind of like their only hit, because I don't ever remember this band doing anything else. But I'm telling you, that was their song. And if you know classic rock, you know that song. All right. So what was
you
the
always
band?
get me with your rock trivia always stumps me.
I know more stuff that won't make me a dime, Jason, than anybody else I know. All right. Let's move
just
on.
Before we get back to work here, we've got a question from Ahmed. It says, would you mind showing us the single line diagram for the makeup connection to the hot water system and how it's working? I'm not quite sure what he's going for there, but did you have a line drawing?
Oh, maybe this one right here?
Buffer tank. Yeah.
You're going to be referring to this right here. Okay. This is, I think we discussed in one of our previous episodes with our backflow preventer and fast fill pressure reducing valve setup, where it is filling the system at the point of no pressure change. And the reason you might want to do it there is because that's the one place where, unless something catastrophic happens, you're not going to have a pressure drop below 12 psi at that point. So that pressure reducing valve won't accidentally be encouraged to allow more water to enter the system. So if you're at the point of no pressure change, the pressure doesn't change at the point of no pressure change, meaning it doesn't go below 12 at that point, you won't be adding any additional water. So it's kind of a fail safe to make that thing work properly, and the circulators won't impact it or anything like that. So that is why we do it that way. I hope that answered your question, Ahmed. Let me, if that's the question you were asking, because sometimes I answer questions that people don't ask. So let me know if that was your question. All right. Hey, look at this. The guys are really getting onto Google. I like it. Very good. All right. Last time I got on stage without a shirt, Jason. Now we don't want to go there. That's just way more.
I haven't had dinner yet.
Hair. It's way more hair than anybody wants to contemplate.
I haven't had dinner yet, John. It's not even 5 o'clock.
That's just Takeo. I keep forgetting it's Takeo after lunch for you. All righty. So we've got that stuff out of the way. I want to talk now about selecting and setting up the boiler pump. And again, this is if the boiler comes with a pump built in, well, that's the one you got to use, right? We're not talking about that. What we're talking about is when you have to field supply a circulator, a boiler pump for that system. Not the system pump's different. We size that. We've gone over how to size that. What I want to talk about is sizing the boiler pump specifically. And the great thing about this is the manufacturers give you so much information in that little booklet that comes free with every boiler. Does anybody know what they're called, what that booklet is called? Yeah, RTFM, says Mr. McGrath. That's right. Read the free manual. Read the free manual. It is the manual, the instruction sheet, the booklet that comes with all of them. All right. There's so much great stuff in there. This is from Navien, not endorsing or not endorsing Navien. This is just, I like the way this is laid out. It gives you good information. Every manufacturer is going to have something similar to this. Now we're looking at the bigger boilers. They're NFB 175, NFB 200. They're larger boilers. And what they do for you is some pretty interesting stuff. First, they'll give you the minimum pipe diameter. That's the pipe from the boiler into the header or into the hydraulic separator or into the buffer tank, okay? It's that piping that we're talking about. In these cases, the minimum pipe diameter is 1.25 inches. Their maximum flow, they're looking at, let's say the NFB 175, the maximum flow through that boiler's heat exchanger, they're looking at 23 gallons a minute and a minimum flow of 7 gallons per minute. All right, so they give that to you right there, the maximum and the minimum. Now down below, they give you temperature rise conditions. And when we're dealing with a ModCon boiler, it makes sense to try to design to as wide of a delta T as possible. If we have a nice wide delta T, that means we got, we have the lower water temperature coming back. We have that boiler run a nice long time to get it up to where we want it to be. So in this example, the maximum that they recommend here is a 35-degree delta T. Some boiler manufacturers, they'll go up to 40. You got to look at the manual and see what they say. But in this case, their maximum is a 35-degree delta T with 100% water. And that means, with the NFB 175H, that means the specified required flow rate through the heat exchanger is 9 gallons per minute. And the head loss through that heat exchanger is a little less than 1.5 feet, 1.5 foot ahead. So we're talking about 9 gallons a minute and 1.5 feet worth of head loss. That's not a lot of head loss. This makes circulator selection kind of interesting, as we're going to see in a second here. But remember that we're looking at something that's got not, reasonably high flow, but really, really low head. And we're going to see what happens when we put a circulator in here. Now, this is the Taco 0015 3-speed, standard efficiency 3-speed circulator. Okay, standard efficiency 3-speed circulator. And what we're looking at here is, okay, 9 gallons a minute at 1.5 feet ahead, plus supply and return piping head, a little bit in there. That's going to be a little bit, not even, I'd be surprised if it was another 0.5 foot ahead. But we're looking at this thing, and by golly, putting this thing at speed 1 or low speed is damn near perfect. If you look at this, how this thing lays out, that 3-speed circulator set to low is going to be just about perfect for that 35-degree delta T. Now, be honest. How many of you out there would have thought, before looking at this, would have thought that a 3-speed circulator at low would have been the right circulator to use here and the right speed? Now, be honest. Let me know if that's a yes or you're not sure or whatever. Let me know what you think. Because to me, when I first went through this, I went, oh, wow, that's pretty cool. Scott Ellis says, Scott Ellis, you're an honest man. Thank you for that. All right. Yep. And Eugene would have went, nope, I would have went to medium. That's all right. That's cool. Well, what if we did go to medium? Let's just extrapolate the system curve. Remember we talked a few weeks ago about system curves and pump curves. If I had it set to medium, what I'd really be getting here now is about 12.5, almost 12.75 gallons per minute at almost 4 foot ahead. So that's kind of somewhere between 25 and 35. That's going to be about 20. Let's split the difference. Let's say it's about almost 30, almost a 30-degree delta T. 28 to 30-degree delta T. All right, 28 to 30-degree delta T. Not bad. Not bad at all. Not bad at all. Now, what if we said, I don't know where to set this dang thing. I'm going to contractor no callback mode because I don't want any problems, man. I'm just going to set it to high and get the hell out of here. You set it to high. Now we're looking at about 14.5 gallons per minute. Now that flow rate's at 14.5 gallons per minute. That's going to be somewhere between a 20 and a 25-degree delta. Let's call it 22, 23-degree delta T. That's not horrible. That's not horrible. But did we get the most out of this boiler? That's the question. Did our selection of speed, did going click, click, click up to high, Did that allow us to get the most out of this boiler, or are we intentionally kind of hamstringing what that boiler can do? All right, let's think about that, because that, to me, that says, all right, I'm just setting this thing up. I could have a 35-degree delta T, but I don't want a 35-degree delta T. I'm only going to get a 22-degree delta T. This boiler is not going to be as efficient as it could be, but it's going to work. No one's going to call me up and tell me that they're freezing to death and blaming me. That is until something breaks, right? So think about that. I mean, setting that thing to low, not only we're using as little pumping power as possible, but we're letting that boiler do what it was meant to do, what it was designed to do, what it was born to do, and that's to condense and have a nice nice large delta T. So think about that, because what we do here impacts other stuff too. That's the cool thing. That's the cool thing. Now, a lot of people say, well, just put an ECM on it, put a variable speed on it, it'll be fine. Put a variable speed on it. Hey man, that's no solution. Let's look at the 0015E3, which I think won't be a great solution here. I would say that the standard efficiency is a better solution than the high efficiency in this example, because here's my 9 gallons a minute at a little over 1.5 feet ahead. Well, as you can see, even if I set that thing to low, I'm never, ever going to be there. I'm never going to be there. Where it's going to work is way out here. It's going to be running full speed. It's going to be running its full speed, 44 watts fixed speed pace, and I'm going to be at about 13 gallons a minute. So that means the best I'm going to have is a 25-degree delta T. Again, not horrible, my friends, not horrible, but it's not the best that we can do for this particular job. All right, so this is one of those instances where, hey, I'll put in a variable speed, it should take care of itself. Well, it's not, because variable speed pumps don't know what you have in mind, and they don't think for you. They are obedient. They will do what you tell them. So if I set this thing to low, I'm working out there on that far end. Does that make sense to everybody? Does that make sense? Now, question, Dave, I'm glad you asked. Could you use a delta T circulator? In theory, absolutely. Yeah, in theory, absolutely. It just depends on what, the control strategy that we're dealing with. A lot of boiler manufacturers aren't quite sure they want to do this, and they're not there yet. I think a delta T circulator is going to be a great solution for here. A better solution, and one I think is going to be the next leap forward in technology here with boilers and with circulators, is going to be the boiler will tell that circulator through a 0 to 10 signal how fast to run. That's going to be the next thing. They do that in the larger boilers. I think we're going to see that evolving into smaller and smaller circulators. That's going to be the best solution, in my opinion.
Yep, absolutely agree there. Yeah. Pulse width modulation or a 0 to 10 on a smaller circ, and off to the races.
Yeah, let her buck, man. The boiler control can tell that circulator how fast it wants it to run for its own maximum efficiency, and that's really going to be the best solution, I think. Is that right?
All right. So there's one question from Ahmed.
Yeah.
Till now, I'm saying it's not suitable as pump performance. It's laying at the end of the pump performance curve, but it's the best and as head and flow. I think I know what he's saying there.
Yeah, I think, and Ahmed, if you're talking about a base-mounted Mongo pump, big commercial pump, I absolutely agree with you. You want it in the sweet spot of the pump performance curve,
right?
With a little, fractional horsepower, 50, 60, 70 watt circulator. It's not going to be that. It's not going to be that big of a deal. I think it's going to work. It's going to work okay. It's not ideal. It's not, your best efficiency point. We're talking about these little circulators, a little AC wet rotor circulators, at best 27, 28% efficient water to wire efficiency anyway. If we're down to 20, okay, well, that's just the way it is. The little pumps, it's not going to be as big of a deal. You're talking about a 250 horsepower pump. You and I are having a different conversation. Absolutely correct. And you would definitely be correct on that. Little pump, it's one of those things. The smaller the pump, the smaller the worry, or the smaller the concern. Okay. Let me know if that makes sense to you, my friend. All righty. Now you really want to dial in the flow. Then you start looking at like the 0018E and set it up in this. You can set up in the Bluetooth app, and you can adjust to the flow rate that you want. By using the app, you can set this thing up to give you 9 gallons a minute, and it'll work right at 9 gallons a minute. And you electronically set that thing to 9 gallons a minute, and you are set. All right. That's maybe the best solution for something like that with a little wet rotor circulator, other than say the 3-speed. Very good, very good. All right. Now, why does any of this matter? Why are we worried about this circulator sizing? What difference does it make? Well, it matters because of this little setup right here, those closely spaced T's, okay? Because you got to remember, what goes into a T must come out of a T. All right, that's the lesson of the night. What goes into a T must come out of a T. So we're gonna blow some mathematical minds here. Okay, you've got to get your addition and subtraction hats on. So here's a system. All right, let's say we got a big system, 140,000 BTU load on this system. At a 20-degree delta T, 140,000 divided by 20 times 500 or 10,000. My system flow rate, with all zones calling, my system flow rate is going to be 14 gallons a minute, right? It's 14 gallons a minute. Now, that's on that system. With the boiler, I'm going to be working with that NFB 175H, 35-degree delta T. So my boiler flow rate is going to be that 9 gallons a minute that we were talking about. All right. Now, if I've got 14 gallons a minute going out to my zones, on the return side, unless something really weird happens, that return flow rate should also be 14 gallons a minute. I'm going to stop for a minute and let that sink in, because that's front of the room thinking right here. I got 14 going out. I got to have 14 coming back. That's just the way of the world. Now, with all zones calling, okay, I got my 14 gallons a minute going out and my 14 gallons a minute coming back. Now, my circulator, 35-degree delta T, 9 gallons a minute. That's what I want going through the boiler. That's 14 gallons a minute is going into one branch, is the Gazinta part of the T. Whatever comes out of the two other holes, the Gazauta holes, has to equal 14. Well, I'm yanking 9 out, right? I'm yanking 9 out for the boiler. That's boiler circulator's doing that. It's going through the boiler, it's boiler rate and it's heater rate, and it's coming back warmer. It's dropping into that second T at a rate of 9 gallons a minute. What's going on in between those two T's? Somebody tell me the flow rate and what direction is that water flowing? All right. I told you I was going to challenge your math skills here. All right. What's going through what GPM is going through that pipe in the middle, and which direction is it going? We got, okay, Aaron's
Bruce
got
said
it.
5?
Yep. Aaron's got it. James, it's 5 gallons a minute. It's 5 gallons a minute. All right. And it's going from my right to left. I don't know what that would look like to you. I guess it would look to be the same, right? Yeah, it's going to the left. Everybody point to the left. There you go. Yeah, and it's flowing out of that first tee and into the second tee. Now, into the second tee, I got 5 plus 9 equals 14, right? Everybody's happy. Everybody's happy. But what if we only had one zone calling? Let's say only one zone was calling, and that's 5 gallons a minute. All right, so I got 5 gallons a minute leaving that first tee. I got 5 gallons a minute coming in that second tee. Now let that boiler pump comes on. That's 9 gallons a minute going out into the boiler, 9 gallons a minute coming back from the boiler. Now what the heck's going on? What's the flow rate through those T's, and which direction is it going? Yeah, Patrick's got it. It's 4 gallons a minute.
Yep.
And it's going
back to the return.
Back into that return T. So now here's the thing. I'm mixing 4 gallons a minute of hot boiler water with 5 gallons a minute of cold return water, and I'm sending that back up to the boiler. The boiler doesn't know what to do, because now that water temperature going back to the boiler is going up, right? Because I'm mixing some hot boiler water with that return. The boiler now, that 10-minute minimum runtime we talked, this is why we don't have that 10-minute minimum runtime with closely spaced T's. All right, because the boiler just doesn't know what to do. This is we're telling this boiler, go ahead, short cycle, you're fine. Short cycle all you want. We don't care. That's what we're telling the boiler to do. All right. Now, if we oversize that circulator on the boiler, let's say we put that 3-speed circulator on high, or whatever. We have a 20-degree delta T. We've oversized that circulator to the point where we have a 20-degree boiler delta T. All right. So I got now all zones calling 14 and 14. That's 16 gallons a minute. 16 gallons a minute. Now it doesn't matter what I do. I will always, every time that boiler fires, I will always have some hot boiler water going back into the return. Always, always, always. This is the best scenario you're ever going to see. Again, that boiler short cycle. When we set that thing click, 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 we go up to high speed just to be safe. We get closer and closer to that 20-degree delta T. We boost the flow through the boiler. All right. That flow's got to interact with the flow through the system. And that flow through the system is going to change all the time, right? It's going to change with how many zones are opening and closing. If you got delta T pumps on that system, it's going to the flow is going to change what zone, depending upon what zones are calling and how warm it is outside. So this is going to happen. What we're trying to do is make sure it doesn't happen a lot. All right. Here, in this example, we have made sure that it's going to happen every time that boiler fires. And the very best scenario that we could possibly hope for sucks. Okay, that's kind of what we're dealing with here. All right, that's just the reality of this situation. More ModCon boilers are piped up like this way than anybody wants to acknowledge, which is why my guy said to me the other day, yeah, we don't put those in. I really rather not put those things in because I got nothing but trouble. It's not that the boiler sucks. It's not that the circulators suck. We just don't, they're not playing well in the same sandbox. We got to make sure they play nicely together. All right. And it gets even worse with just one zone column. Look at this, man. Now I'm going to have 11 gallons a minute of hot boiler water going back into the system, going back into the boiler and mixing with the 5 gallons a minute of return water temperature. So not only am I screwing up my return water temperature, I don't know what temperature I've got going out to the boiler now, or going out to the system now. So just think about what this is going to look like. And the only thing I come up with is holy crap and a cracker. Holy crap and a cracker. So,
But you can have multiple closely spaced teams too in a system, right?
Well, on the delivery side, you only have the one on the boiler
Yeah.
side. On the delivery side,
Right.
you can do multiple closely spaced tees.
Yep.
Now, we've had a lot of folks say, well, let's just put a variable speed pump on the system, and that'll vary the speed, and we can maybe then make this better. Not so much. Let's take a look at this. All right. So let's say I'm going to use a 0026E for that 34 for 14 gallons a minute at about 8 feet ahead, set at low speed. This is kind of what we're looking at here. All right. So I've got my 14 gallons a minute, 9 gallons. Okay. Same as before. Same as before. All right. So that's all good. But let's say my smallest zone, 3 gallons a minute, 6 foot ahead is calling, and it's really going to be at about 3.5 gallons a minute. That's really where it's going to be, because that's where the system curve intersects the control curve. So now I got 3.5, 9. Holy crap and a cracker. That's what's going to happen. So there's no way to prevent this. Okay. There's no way to prevent this as long as you have a fixed speed circulator on that boiler. And a fixed speed circulator is going to be it'll be a delta P circulator, even though it's quote unquote variable speed. When you put that delta P circulator on there, it's only going to change its speed based on changing pressure differentials. The pressure differential is never going to change going through the boiler, so it's going to run one speed, and that's that. All right. A delta T circulator in theory should work well, but again, how does it mesh with the boiler's control and turn down ratio is always a question. Check with your boiler manufacturer before you do that. That's the important thing. Some are cool with it. Some say, nah, I don't want to take that. I don't want you to be my experiment. Again, the best solution will be, as it gets down to smaller and smaller systems, where the boiler with a 0 to 10 signal will tell that circulator how fast to go. And that's going to be the best solution for the boiler circulator going forward, in my opinion. But anyway, there we go. So we haven't even talked about water temperatures, okay? We haven't talked about water temperatures, because just remember, all these temperatures are mixing, right? We got the system designed to a 20-degree delta T. We got that boiler set up for a 35-degree delta T. But if my flows are off, again, remember what happens? Let's say I'm mixing X amount of 150-degree boiler water with X amount of 120-degree return water. That boiler wants to raise the water from 120 to 155, let's say, but I'm mixing 155 with 120 before sending it back into the boiler. It's a lot of double talk, but you get the idea. I'm heating the water up before sending it back to the boiler, which is not really what we want to do here. And then I'm going to short cycle that boiler. Maybe I've got, instead of having instead of mixing a certain amount of 155 degree water with a certain amount of, let's say, 120 degree water to get 140 going out to the system, now I'm going to more than likely just have 155 going out to the system, which means my return water temperature is going to be higher, which means I'm mixing hotter return water with hot boiler water, and the delta T is going to be even smaller. All right.
Is there some math? Is there some math coming up here, John?
Oh, you know what? I had the math in here. I took it out because, my God, I don't want to
It is
scare the hell
complicated.
out of people. You don't need to know. If, as long as you know that this is going to happen and it's not good, you don't need to know the math. But there is math here, and you can actually pinpoint what that water temperature will be and how badly that'll mess stuff up. And now you got a boy who doesn't know what to do. So now that we've promptly scared the hell out of everybody, what do we do to deal with this? We go back to our friend, the buffer tank. The buffer tank, as we said in earlier, it's designed to stop that ticking time bomb, because all of these flows and temperatures that we've been talking about and how they're going to getting all messed up with each other, that's the ticking time bomb. That's the thing that's going to short cycle the boiler. That's the thing that's going to wear out components and parts and pieces and moving stuff, expensive service items. That's the stuff that'll kill those service items faster than you know what. And that's one of the reasons why my guy just yesterday said, I don't like putting those things again. Nothing but problems with them. Fix my heat pump first and then we'll talk. I didn't want to scare him off, but it is largely a self-inflicted wound. You just got to understand about certain. I don't know how many times we said this during Takeo After Dark, Jason. You I must be sounding like a broken record to you, because you hear me say this all the time. Is circulators have more to do with system efficiency than we have ever given them credit for. Here's a perfect example. And what if I oversize that system circulator, by the by? All right, we were assuming that, hey, I needed 14 gallons a minute on the system side. I'm giving it 14 gallons a minute on the system side. We didn't even enter into the realm of possibility that we could oversize the system circulator, all right, which is going to happen. And that just makes this thing even worse. So again, circulators are so important when it comes to maximizing the system efficiency. How efficiently will that overall system work? Make sure we size the boiler circulator properly. Make sure we size the system circulator or circulators properly, and understand what happens when they're both running. Okay, we said they don't interfere with each other, and in theory they don't, but the numbers, the math interferes with one another. Best solution is going to be this kind of an approach when you need to is a buffer tank, and I think buffer tank more often than we realize is going to be the better solution. You guys always say, well, buffer tank, they're too expensive, man. Those buffer tanks are too expensive. I can't, how do I sell that to my customers? You don't. You sell them a system. Okay, you sell them a system, and here's the system that's best for you, and here's why, and here's how we justify it. You don't say, I want you to put in a buffer tank. We could do the cheaper stuff with closely spaced tees. Well, why do I need that? No, I go to a cheap stuff. No, don't even. It says, what's the best way to install this system? If the best way to install this system includes a buffer tank, that is what you propose. Is that good? All right. That was fun, dude. That was fun.
All right. It was. It's always entertaining. All right.
It is always entertaining.
You want to do the spinning wheel of death?
Have you got it all set up?
I've got it all set up, brother. You know me. I'm ahead of you.
We will. I'm gonna give you the screen in a moment, because I want you to know. I want you to do this, because this will be Jason's first time taking over the screen.
No, it will be my second time.
Oh, your second time.
Oh yeah.
All right. Dude. All right. So, Grand Funk Railroad members, Mark Farner, Don Brewer, and Mel Shocker all hail from Michigan. Shocker came to Grand Funk from another Michigan band, one that scored a huge #1 hit in 1966. What was the name of the band, and what was the hit? What was the name of the band? Question Mark and the Mysterians. I love that band's name. Question Mark and the Mysterians. Yeah, 1966. And their big hit, 96 Tears. What a great song.
We had quite a few right answers there, John. I've got them loaded into the spinny wheel.
That's all right. That's a good thing. That's a good thing. All right. Next week, before we go to the spinny wheel, next week will be our final week of Takeo After Dark for the spring season. We've got some cool stuff planned for the summertime. Going to be different than anything we've ever done before, both in terms of content and in terms of how you consume it. All right, we're going to try a few different things next in the summertime. Hopefully this will be fun for you. We're going to try some experiments and see how it works and see how you guys like it, get your feedback and see if it's something we want to continue. But we got some really interesting possibilities for this summer on how to deliver Takeo After Dark. So that's all coming this summer, but next week in our grand finale for the year, and we will all be together in Cranston, Rhode Island, Jason, for the grand finale. So I got to think we got to get some people in for an audience. We got to make this a party. I'm telling you. I'm telling you.
Podcast type of setup. Yep.
I like it. Yep. So next week, we're going to be talking about domestic hot water recirculation systems. All right. Some of how to size it, how to control it, and the things that can get you into a boatload of trouble if you're not careful. All right.
Real quick.
We can do this the smart way. And it's not hard. It just, you got to just take care on how to size that circulator and how to control that circulator. So that'll be going on next week, which we cannot wait for. All right, Jason, I'm going to turn this over to you.
Let me know when I'm ready to go.
All righty. I think you got to accept now.
Yep, I got to accept.
And share your screen.
You just let me know when you see it.
It's there, baby. It's there.
All right. Let's see. Do we see a spinny wheel?
We see the spinny wheel.
All right. Very good. Oops. Very good. All right, John. First of all, how many winners are we going to have today?
We're going to have. Well, Dave's got to send these things out. So let's have one grand prize winner for the backpack cooler.
For the cooler backpacks, one for the cooler.
And 3 T-shirts.
And 3 T-shirts. And of course, we have all your information from your sign up, so we'll know where to send these items. So 3 shirts. All right, shall we?
Spin away, brother.
All right.
The wheel of death.
I don't know I had to put the wheel of death up there. I think it's the spinning wheel of death. What do we got? My screen is obscured there.
And Furet. All right. Furet gets the cooler backpack. All right.
One for the cooler. All right, Furet.
Now make sure you click remove there. That'll take his name out so we don't run on it again.
Yep.
You the man.
Gotcha. Give me a second. My screen doesn't like the transition here. All right, so just X out there.
No, just hit remove. See where it says remove?
Yeah.
Right underneath his name.
Yep.
There it is.
I got you. I was having trouble getting back and forth from the two different, from our podcast or webcast to this. Okay, next spin for a T-shirt is
round and round she goes. Where she stops, nobody knows. James Winslow. All right. I think James might have won. James won already too. We got guys
several this year.
Guys are getting a whole new wardrobe out of this. This is awesome.
Winslow. Okay.
All right. 2 more T-shirts.
2 more T's.
Scott Ellis. Congratulations, Scott.
All right. Cheers. And final T-shirt. Let's go. Good luck to everyone.
Who could it be?
Who could it be now?
Ooh, is it going to stay with you, Aaron? Aaron Bruce. Congratulations, Aaron.
Aaron Bruce.
I think Aaron's got a nice little wardrobe going too. Congratulations, guys.
All right. Congrats, gentlemen.
All right. All right. I'm going to take this thing back right here. All right. Cool. So excellent. How? Let me know what you guys thought. How did this thing work out for you? Was it useful? Anything new or different or interesting that you learned tonight? Give me one thing. Did this come as a surprise to you? This information, was this an eye opener? Is this something you kind of sort of knew but didn't know the details? And will this impact how you pipe up boilers going forward? So I guess that's 3 questions. I guess so. Let me throw 3 questions at you. So is this going to change things, change or impact how you do things going forward? So we got a refresher, we got an eye opener. So both are good.
That's good.
Yeah, it's important. I mean, this is the stuff, to me, this is for residential hydronics. This is advanced stuff because now this is how things impact one another. we said it a lot, and again, Jason, you probably have PTSD hearing me talk about this all the time, is that we can get away with a lot. All right. If we didn't do anything here, if you just said, yeah, throw the 3-speed in on high, let go, I don't care. People going to freeze to death? No. System going to work? Yeah. When you do a combustion test on the boiler, is it still going to read 90 something? Yeah. Everything should be just Jim dandy, right? Everything should work. This thing's working like it's supposed to, but it's not. That's the thing. It's not. It's not a system at that point. It is a collection of parts. As we've said so many times before, a system by definition is something where, the whole is greater than the sum of the parts. Doesn't take a particularly intelligent guy to slap together a bunch of parts, keep the water on the inside, have it make fire, and keep people from freezing to death. That's not hard. What is hard is what it requires a professional to do. The professional understands the stuff that we talked about tonight. He understands that the circulator I choose has an impact. The boiler I choose has an impact. The size of the pipe has an impact. I got to select these things carefully so they work together harmoniously. All right. So we give the customer something that's going to work right, work well, last long, and give them the efficiency that they are paying for. That's the important part, because a lot of times, people aren't paying for heat. They're paying for heat and comfort and efficiency, right? As long as they're not freezing to death, we think that we've done our job and everything's fine. Yeah, okay. Fire, a can of gasoline and some matches will keep you from freezing to death. We can do better. One of the reasons we have shirts with our name on it, company name on it, and vans with our company name on it is, people expect, you're professional. People expect that this is the kind of thing that they come to expect. Otherwise, they would hire the handyman. So I hope this was helpful. Again, usual question about can a buffer tank be too big? No, it is impossible for a buffer tank to be too big, other than you can't get it through the door. Okay, then it's just too big. In theory, there's no downside. It's like an expansion tank. In theory, there's no downside to oversizing an expansion tank. There's no downside to oversizing a buffer tank. It's just a matter of what gets you as close to where you need to be, at the most reasonable cost. I think that's the question. But yeah, buffer tanks you can't oversize a buffer tank unless, as we said, you can't get it through the door. Cool. Excellent. All right. Great content. Well
delivered, Jessica.
Why, thank you. We appreciate that. It's always nice to hear. All righty. Well, hey, last minute questions, folks. If you have last minute questions, great. If you don't, we'll hang on for a few minutes just to let the stragglers come on in. And really, any questions about anything? It doesn't have to be about tonight's material. It can be about anything that's driving you up a tree, about TACO or hydronics or the state of the Red Sox. But there's hope for the New England Patriots. That's all I can tell you. There's hope. We're on the road to recovery and redemption. I believe that. I can tell by your response out there that it really matters to you guys.
I'm just gonna keep my mouth shut on this one. I'm just gonna keep my mouth shut.
That's all right.
You guys had a good run. We're a little tired of hearing about it.
Hey, listen, can you imagine the nightmare we've been dealing with since 2019? We have not experienced the joy of championship for our football team since,
I know, it's
almost 7 years.
Been a long
6.5 years. The pain is real.
Poor thing. Poor thing.
Oh, well, hey.
I got the world's smallest violin playing here for you.
Make sure you get those fingers right there, Sunshine. All righty, folks. Hey,
looks like everybody's signing off. So
all right,
let's go to bed. Let's go to sleep.
Hey, thank you, folks. Appreciate it, Jason. We'll see you next Wednesday. And
I will see you if I don't see you first.
All right. Then you just duck out of the way. Thank you. I appreciate that. Have a great night, everybody. We'll see you later.
See you guys. See you, everyone.
Night.